So here's an informational example that says use wave pulses to show constructive and destructive interference. So let's go ahead and look at the slide here and see what the answer is. I have on one side constructive interference, and there are two pulses here. And the way you should look at this is these two pulses are moving towards each other. And so as we move down, you're seeing kind of the time-lapse view of what happens. And the thing to notice is when the two of them pass through each other, there's briefly a larger wave pulse there because the two of them sum up. And then they move through each other and continue on their way unaffected by the fact that they had actually just passed through one another. So interference is sometimes a misleading term, and both constructive and destructive, particularly I think destructive interference implying the destruction of something, can be misleading because really at the end of the day, the two wave pulses come out completely unscathed. The difference with destructive interference versus constructive interference is that here one of the wave pulses is an up pulse and the other one is a down pulse. So when they pass through each other, the act of summing up those two pulses winds up canceling out. And so briefly, the medium is completely flat. And then the waves reconstruct out of that. Now you can say, well, how does that happen? This is just a snapshot at one instant in time of the medium. The medium actually still has motion. There is still kinetic energy there. And a moment later, it's that kinetic energy and the motion, you can maybe even say the momentum of the medium, that leads to the wave pulses reforming and continuing unaffected by the fact that they passed through each other.